Hello children, we have already begun with chapter number 15, that is probability of standard 10th. We have discussed a lot about the details of probability. Now we are beginning with the exercise, that is exercise 15.1. Let us begin with question number 1. These are complete the following statements. The first one, probability of an event E and probability of not E. When you add them, the answer will be always 1. Next, the probability of an event cannot happen is 0. If it is not possible, actually we have studied about all these things in the last video. Here, if the event is not happening, so its probability will be 0. Such an event is called as an impossible event. That is the name given. Next, the probability of an event that is certain to happen, it is always 1. And it is called as a sure event. The next sub-question, the sum of the probabilities of all the elementary event of an experiment is always 1. We have learnt it beforehand only. Probability of E1, E2, when you add them up, the total is always 1. The next sub-question, that is the fifth sub-question, the probability of an event is greater than or equal to 0 and less than or equal to 1. Probability always lies from 0 to 1. Next question is, which of the following experiments have equally likely outcomes? Explain. Now here, a driver attempts to start a car. The car starts or does not start. Here, we are not going to consider it as an equally likely event. It is not an equally likely event. The reason is, it depends on the condition of the car whether it starts or not. If the condition of the car is perfect, for every attempt it is going to start. And if the car is not in a good condition, it won't start. It depends on the condition of the car. So we are considering this to be not equally likely event. Next, a player attempts to shoot a basketball. He or she shoots or misses the shot. Now this is also an example of not equally likely event because it depends on the player's capability. If this is a very good player, he or she, the one who is playing here, is a very good player. It may happen that he or she is able to shoot each and every ball, gets the basket every time. And if he or she is just a person like me or some of you who has never played, in that case, he or she may go on missing each and every shot, or he may get 1 or 2 baskets. So it depends on the capability of the person. So we are not going to consider it as an equally likely event. A trial is made to answer a true-false question. The answer is right or wrong. Here, there are equal chances of getting a true or false if you just try it. 50% chance of getting it correct, 50% chance of not getting it correct. So, we will decide that this is an equally likely event. A baby is born, it is a boy or a girl, so it again becomes an equally likely event. Then basically the population is divided into 2 equal parts, that is, it is 50% and 50% boy or a girl. So it is an equally likely event. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? Now, you must have seen in all the games, the beginning of the game is decided by tossing a coin. So, how come we can say that it is a fair way of deciding? The reason is that getting a tail or a head is equally likely. The chances equally likely, or we can say the probability is equal. That is why we say that it is always fair to decide a game, the beginning of a game, by tossing a coin. Which of the following cannot be the probability of an event? Now, in these, one number is a negative, and we have already studied that probability can never be a negative number. So, B option, that is -1/5, will never be an answer. Next question, that is the fifth question. If P of E, that is probability of the event, is 0.05, we have to find out the probability of not E. Now E, that is the event, and not E, that is the not event. They are called complementary events, and we have studied that complementary events add up to 1. So probability of getting not E will always be 1 minus probability of having E. So the answer is 1 minus the given number 0.05, which is 0.95. Next, a bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy? Now there is a bag which has only lemon flavored candy. That means there are no orange flavored candy. So the probability of getting an orange flavored candy will be 0, because it becomes an impossible event. The thing which is not there cannot be taken out. So it is an impossible event, and the probability of getting it is 0. The second sub question is getting a lemon flavored candy. Now the entire bag has only lemon flavored candies. So the probability of getting it is equal to 1, because it becomes a sure event. Each and every candy is lemon flavored. You take out any one of it, it has to be a lemon flavored. So it is a sure event, and its probability is 1. We are going to study more and more about probability in the coming videos. Till then, keep trying. Thank you for now.